This is the leXsolar H2 ready to go, our system for experimental research into various fuel systems for the secondary education levels 1 and 2. The devices are clearly laid out in the suitcase for safe and easy transport. Already today there are different fuel cell systems in energy supply and automobility. With this case we would like to perform an experiment in which we compare the PEM fuel cell with the SOFC. For this we need the leXsolar base unit. We remove the power module because we do not require it in this experiment. Furthermore, we need the motor module, the SOFC fuel cell with cables and stand, the gas burner, the PEM fuel cell and protective packaging, the associated module, the H2 charger with power supply, and an H2 storage with valve and hoses. In addition, a lighter and distilled water is also required. Now we have all the equipment to assemble the experiment. For the experiment with the PEM fuel cell, we need hydrogen. We produce this with the H2 charger. To this end, we first fill distilled water into the water tank. Then the power supply is connected to the charger. Now the indicator light should be flashing green. Next, we turn the H2 storage in the provided holder until the lamp continuously lights red. In this case, the storage is filled with hydrogen. While the charger is filling the hydrogen tank, we perform the test with the SOFC fuel cell. For this, we first need the base unit. It has slots for up to 3 modules which can be connected in series or parallel. On one side, we attach the stand module to the base unit. Then we fix the SOFC fuel cell with the plexiglass protection to the stand. It must be ensured here that the opening of the protection is over the hole of the stand module. We are in fact putting the gas burner in this hole, whose flame should warm the fuel cell through the opening. Lastly, we put the associated cables in the fuel cell and the module. Pay attention to the correct polarity between the fuel cell and the module plate. We put the motor right next to this module. Now we have a simple circuit of producer and consumer and can now start the test. For this, we turn on the gas supply of the burner and ignite the propane-butane gas mixture. Then we push the fuel cell carefully into the flame until the tip of the flame touches the fuel cell. As we can see, the piece of metal is heated. The functional principle can be explained so that the oxygen atoms absorb electrons at the cathode. Owing to warming, they can pass through the membrane as ions. Due to the formation of water molecules with the hydrogen from the gas, the oxygen ions release their electrons at the anode. The current flow between the anode and the cathode can then be used as a consumer. The motor begins to rotate. In the second part of our experiment, we want to use the PEM fuel cell. For this, we turn off the gas supply and replace the SOFC module with the PEM fuel cell. We then take the PEM fuel cell and plug in the connections of the module plate. It is important to ensure that the polarity is correct, that is, red to red and black to black. Now we attach the hose with the pin in the upper opening and join the PEM fuel cell with the valve for the supply of hydrogen. Finally, we put the fuel cell in the module. We take the storage out of the charger and screw it to the other side of the valve. With the hydrogen from the tank and the oxygen in the proximity, the conversion to water begins in the fuel cell. Electrons flow again through an external circuit and can operate a consumer. After a short time, the motor also starts to rotate. In the experiment, we have seen that both technologies can be used as a power supply. We have seen that different fuel types are used with various gases and in some cases considerably different conditions such as the operating temperature. In addition to this experiment, 15 more experiments can be carried out. In the related teacher's manual, the construction, execution, and evaluation proposals are described. Experimental protocols can be found in the instruction manual. So, for example, another 2 PEM fuel cells can be used. They are also supplied in a protective foil to prevent dehydration. Using the module plates, the behaviour of the voltage and current in series and parallel circuits can also be carried out. Instead of the H2 charger, hydrogen can be produced and stored by means of the electrolyzer and the gas storage module. The process of electrolysis can be better observed through the transparent membrane of the electrolyzer. The resulting hydrogen and oxygen are stored in the gas tanks, where it is good to see that twice as much hydrogen is produced as oxygen. The electrolyzer can be used in 2 different ways. The first option is that it can be operated with electric current from the solar module. For adequate lighting, there is a lamp available. The second option is to use the power module, which we set aside at the beginning. The power module is a voltage source which can generate voltages between 0.5 and 12 volts in 0.5 increments. It can produce higher voltages than the solar cell and thus operate the hydrogen production faster. Another type of fuel cell available is an ethanol fuel cell. Its performance as a function of the temperature and concentration of ethanol solutions can be examined. For fuel cells, there are also several syringes and tubing to carefully fill the distilled water and seal the modules. Finally, there are also 2 multimeters for voltage and current measurements in the case. These can be connected to the other components via cables. On the accompanying CD, all the experiment instructions and background information for teachers, as well as the experimental protocols for the students, are included. We wish you lots of fun experimenting.